So this is the second video about the first quiz in statistics for year 11 in 2022. Okay, so we must now do exercises 4, 5, and 6. Okay, so exercise 4 says the water temperature in Lake Windermere is measured on the first day of 8 consecutive months from January to August, and the results are shown below. The value for May has been accidentally deleted. Okay, so we have the month and the temperature. Assuming the data follows a linear model for this period, find the regression line of T on M. T on M means that this must be the Y and this the X. Okay, so if we want to graph this, the X will be the M in this case because it says T on M. If it says always, for example, A on B, then the first thing that is named should be the Y and the second one, the X, right? So to do this, the way to solve it is just go into the calculator and write on the first list, the value for X, which in this case are the months. So 1, 2, 3, 4. Since the 5 we don't have it, we just for continue, right? We won't use that point. So 6, 7, and 8. And then for the temperatures, we have 5.2, 8, 7.2, 8.9, 12.6, 15.5, and 15.4. Okay. So with these numbers, now we must calculate. Okay. So calc 2 bar. So no, instead of calc, we graph this. Okay, these are the points that we are going to use, and now you press on F1, which is calc, right? And now you press on the F2, which is the X, because it's linear, right? If you wanted a quadratic or a cubic model, you would use these buttons, but in this case, we need the linear model. Okay, so we will mostly, like in general, we will use F2 for the linear model. So we get that the equation that we are talking about is the temperature, so Y is equal to 1.52 times the month plus B, and B is 3.68. Okay, check that here we have that Y is equal to AX plus B. So this is why, this is how we know that this is the gradient, the value of A, and B is the Y-intercept, okay? So this is the equation of the line. So use your, find the regression line, then the answer is T is equal to 1.52 times M plus 3.68. Use your line to find an estimate for the water temperature on the first day of May. So the only thing we must do is replace the M, right, with the value of this month, which is May, which is 5. So we just go and do 1.52 times 5 plus 3.68, and the answer is 11.28. Okay. So to 3 significant figures, we will write 11.3. Okay. So let's go and check the answers. We have the equation and 11.3, right? So exactly what we had. Perfect. So explain why your line should not be used to estimate the value of M at which the temperature is 10 degrees. Well, since M is a discrete value, right? It doesn't make that much sense to calculate M from T, right? Because what happens if we get that M is equal to 3.5 or 3.6? What would our value of M be, right? So the equation we have is to calculate T from M, right? So this equation shouldn't be used for what we are asked. Okay, you can go and read the marks. Okay, that I will leave attached in the YouTube video and everywhere. So explain in context why your line shouldn't be used to predict the value for December. Well, if we understand like real life, right? Like the temperature isn't linear, right? Like the water temperature isn't linear because of for example, we have, it depends if we are in summer, winter, autumn, and so on, right? So this is why it shouldn't be used because the linear model is not going to be real for the 12 months, right? And then state a more appropriate model for the water. Well, this was kind of tricky. You can go and read the answer, but this wanted to I mean, wanted you to think about, let's say we have on the first, like we have something quite linear for the first month, but then in December, I mean, if we are in the North Pole, in the North Hemisphere, right? Like in December or near December, we are like the water temperature will drop again, right? So we will have something like this, and then another year starts, and we get again like something like this, and then like this, right? So this question wanted you to think about like trigonometric functions, but I mean, still, don't think about this a lot. So we have Hafisa harvested 49 mangoes, right? And the modal group. So the modal group is the group for which more mangoes are there, right? Are in that group. So the answer is basically this group, okay? But check that the way to write the answer should be either like this, or like this, or like this. Not, I mean, the IB says do not accept 400 slash or this thing 500, okay? Then use your graphic calculator to find an estimate. For this, what we should do is, and this is important, statistics, right? And the values that we are going to write are, in the list 1, the weights. So since we have a range, we are going to write the medium, like the number in the middle, right? So 150, 250, like this, right? And in list 2, we are going to write the frequency. So 4, 7, 16, and 8. Now we are going to calculate this, but for using one variable, we are going to go to the setup, and we are going to tell the calculator that the frequencies isn't 1. The frequencies are list 2. So we have to press F2 and now write the number 2, okay? So list 2 is going to be the frequencies, like the frequency list, right? Now that we have this, we calculate for one variable, right? Because the only variable is the weight of the mangoes, and we get that the standard deviation is this one, 115.265, and to 3 significant figures, the answer is 115. Okay, if you check the margin, that's the answer. Okay, so the histogram, basically, this is what we are asked, right? Like 4 of this group, 7 of this group, 14, 16, and 8. And then the last exercise is similar to the previous one, right? We have the temperature and the hot chocolates, and we want to find a relationship where, check that the y value is going to be this one, right? Because the equation has the gradient multiplied by t. Okay, so now this is going to be y, the number of hot chocolates, and this is going to be b, x, the temperature, okay? So if we come here and we clean, first of all, everything, and we write first the value for the list for x, right? So we have 14, 8, 4, 18, 13, and 11. And then for the hot chocolates, we have 79, 143, 191, 58, 84, and 105. Now for this, we go and click on graph 1. And now that we have this, first of all, you can try and think of, will the gradient be positive or negative, right? And since we are seeing that this is decreasing when we move right, then the value of A should be negative, right? So calc F2 again, and we get that the equation is the number of hot chocolates is going to be minus 9.85 times the temperature in that day plus 222, right? Because we need 3 significant figures as always. So A is minus 9.85 and B is 222. Now, the correlation coefficient, we only need to know what it is, and it is the value of R here. Okay, so we will write just R is equal to minus 0.981. And now use the regression equation. Using the regression equation, estimate the number of hot chocolates that Lucy will sell on a day when the maximum temperature is 12. Okay, so since T was the value of X, we should use this to estimate H, right? So we will just go to the calculator, for example, and do minus 9.85 times the value for the temperature, which is in this case 12, plus 222. And the answer is 103.8. Since we are talking about the number of hot chocolates and we want to estimate it, then the answer would be the nearest integer, right? So in this case, 104 should be the answer. Okay, if we go to the mark scheme, we can check. Okay, so there is something different over here. Well, actually, look, I mean, take a look at this says here 103.8 from 3 significant figures. So if you round this up as we just did, then we would get this 103.8. But I mean, if not, for example, I think here the mark scheme used these values. So it used these exact values, like the calculation was minus 9.8463687 plus 221.592178. In that case, then the IB got this result and 103. But 104 should be also correct. Okay, that's all.